Welcome to this Vlog5 on agility skill, and specifically the Illinois agility test. Starting off, there is no precise definition of the term agility, but as proposed by Young and colleagues, it comprises both mechanical and structural properties and perceptual factors, the latter both present with or without contextual interference. I have added feedback and feed-forward loops through both proprioceptive and cognitive plus subcognitive processes, as I find these loops of vital importance in agility skill. Of this, both extrinsic and bodily intrinsic input can be important. This we will investigate further. Putting this to practice, I've used the Illinois agility test that combines short distance sprinting with turns and maneuvering as shown on this graphic. The first attempt at this agility drill was quite staggered for me. I had trouble reaching top speeds and especially generating locomotive forces in the turns and maneuvering. The time was 20.07 seconds. We know that ground contact times are larger during agility movements than at higher velocities. The ability to produce pertinent force is of essence. So I tried experimenting with stump jumps, both flat-feeted and on the front part of the foot to load the Achilles tendon. This to stimulate longer ground contact times. Since the stump jump both bilaterally and single-leggedly employ gravitational forces, it can mimic the absorption of sudden force and then change the direction of force, which can be similar to the change of direction in agility. Changing the one-legged drill to a push-off jump can make it more transferable to the agility task of turning. Adding a hurdle and focusing on forefoot contact can make this more specific to angular direction of force and rapid ground contact when changing direction. Doing a slow motion analysis of turning, we observe, by the red arrow, that my right knee falls into valgus. This stresses the importance of lower limb stability and strength, both via strength training but also by employing the stump and push-off jump to learn force absorption and redirection. We also note that the muscles of the torso have to resist rotation and promote the process of turning in conjunction with the crossover step. Going further into these physical constraints that can limit agility skill for the individual athlete, I experimented with medicine balls as a tool to promote rapid braking and subsequent acceleration via the muscles of the abdomen, lower back and hip. Research by Feigenbaum and Mediate, Bhaskaran and Earp and Kramer have suggested that medicine ball exercises can improve measured times in agility. Furthermore, the use of medicine balls can achieve angular specificity, typically not promoted by traditional strength training. This tool can also be used on one leg to increase demands of stability in the stance leg. So combining rotational forces with one-legged stance can promote a transfer to the change of direction demands in agility. Adding a water ball in this closed skill can promote higher levels of autocorrection and thereby intrinsic feedback. So a drill that seems to promote physical qualities can serve the purpose of creating new motor strategies. By this, the system should learn more acute readiness to solve the movement skill of agility, both by enhancement of physical competency and adaptability in the use of sound motor programs. After working these physical skills, I ran the test again. Time was 18.97 seconds, so better. I still felt, though, that my coordination of movements was lacking. I reflected on my experiences and turned to a constraint model, as presented here, modified from Winkelmann. The size and the distances covered in the test is the environment which will dictate the movement patterns. So to challenge these, the test can be made into a drill, either smaller or larger in size, to promote coordination or speed components. Making the drill harder by adding circles will also promote the ability to use feedback feed-forward processes better. So a larger base in varied movements and an ability to discard physical demand will optimize the employed motor strategies for agility skill. This by enhancing the focus of the task and not the limits in physical capabilities. I learned that agility is a complex arrangement of physical skill and abundant motor strategies. Also that motor strategies should be challenged to a point of failure and with variability to evolve.